Having watched the videos, let's apply the notes. When we say side, 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 what does that mean? That we've got three pairs. There's one pair. There's another pair. And there's a third pair. Three pairs of congruent sides. What about side, angle, side? Where does that angle have to be? Good, in between. Has to be able to go side, angle, side. Would you guys please draw a picture here that reflects ASA, angle, side, angle? Annotate your notes to show that. Maybe something like that. And how does it change for AAS? Do you guys have the Mario theme song in your head when you're doing this? Doo-doo-doo, doo-doo-doo, doo-doo. And did I teach you RHL in that video? I don't know that I did. Okay. What RHL stands for is that it's a right angle, which we're showing with the right angle, and the hypotenuse, and then either one of the legs. In other words, this is a special case of ASS, but one that does work. And what you're going to be doing is writing proofs. So these are lists of things that you might put in the reason side of proofs. And eventually you'll get to the point where after you say that the triangle is congruent to the triangle, you can say CPCTC, which says the corresponding parts of congruent triangles are congruent. So for example, if I want to find out which side is congruent to AB, what would I say? First two letters here, first two letters here. What if I wanted to find the matching one with FD? Good. And what about BC? EF. And it works not only with sides, but also with angles. Angle A would be congruent to what? Angle D. Angle E would be congruent with angle B. Angle F would be congruent with angle C. So let's write some proofs. And I'm going to start you off pretty darn easy. I'm giving you some information here. And what I'd like to suggest is each time you take one of the given pieces of information, you do two things. In addition to writing it under your statements, with the reason given, you come up and you annotate your picture. Second statement is BC is congruent to EF, also given. And angle B is congruent to angle E, also given. So now, two questions happen here. First, what do we call this? Is it SSS, SAS, ASA? You guys agree? SAS? And they're both SAS matched, right? The next question is that one of the ones that proves triangles are congruent? Yeah. It is. Therefore, we're going to say that the triangles are congruent using the reason SAS. When I write the triangles are congruent, first one's free. What should I name this triangle? ABC, okay. But now that I've claimed what order it is, this one has to match it. What do I name this one? DEF. And that's it. QED, I'm done. Please try number 2 yourself. Hey, what do we get? Are these two triangles congruent? By what reason? AAS. And that's one of the ones that works, so we're good. Do these last two, please. All right. How about number 3? What did we get here? Side, side, side. 4. ASA. How's this feel? 5. Okay, this seems really easy. I can do this. 3, it's sort of making sense. 1, I'm so confused. Okay, good. Hands down. These are obviously very easy because all of the facts are given. All you're doing is determining if the triangles are congruent. You'll continue to finish this page with that. Let's take a look at number 9. How do I start? With a given still. And when I put it in here, what do I do? BA is congruent to CD. Okay, second fact. Also given. All right. Now what? Do we have enough information to say the triangles are congruent? How many pieces do we need? 3. Do we have 3? No. We do? What is it, Jason?
We have X, and X is the same vertex for both of them.
You're in the right ballpark, but your nomenclature, your naming is wrong. They're vertical angles. Which angles? These ones here, right? So how do I name this angle? Say again? 180 minus X. No, X is a point. No. Remember we talked about naming angles. I can name this angle D because it's obvious. I can name this angle C. I can't name this angle X. What do I name this instead? Oh, so close. Angle CXD and angle BXA. First, we state that they are vertical angles. What's our justification for saying they are vertical angles? Good. Definition of vertical angles. Having now said they're vertical angles, I can say angle CXD is congruent to angle BXA, because if they're vertical, then they're congruent. And we've said they're vertical, so they are congruent. I'll mark those now. Now does my triangle have what I need to claim the triangles are congruent? What do I put as the justification?
Angle.
Yes, and not quite. Angle, angle, side.
Oh.
Right? The right pieces in the right order, but you got to put them in from the front. QED, we're done with that one. What made that one harder? It wasn't given to you. You had to interpret it from the picture for the third fact. You had to apply what you know from the past to generate the third piece of information. Your homework tonight is to finish up those other couple of quick ones and do this page. Each of these is a proof. And what I suggest you do is pull your pages apart here. And I've done the first couple for you. Notice that for this one, our given says BI is congruent to WO, and IBL is congruent to OWL. BL is congruent to WL. Therefore, we can prove by side angle side congruent. Let's take a look at number 3 that I haven't quite done for you yet. YF is equal to NY given. So let's mark that. UF is congruent to UN given. And then I suggest that maybe you should do YU equals YU. Why is that true? Nice. Reflexive prop congruence. In other words, this leg here is the same for both shapes. It's shared by both. So I can say YU to mean the left triangle or the top triangle and YU to mean the bottom triangle. Does that now give us enough information to say these two triangles are congruent? By what? Side, side, side. Okay, your goal is going to be to finish this side of the page, just 1 through 12. I know that the paper goes on to 15, but you're only doing 12. All right, you have the rest of the period to finish these up.